This video explains what continuity is versus what differentiability is, and this should help you with the prep quiz for 2.5. So first we're going to talk about continuity. Continuity is a pretty simple concept. It's basically a function is continuous everywhere that you can continue drawing on that function and not pick up your pencil. So from -10 to -8, the function, or from -10 to -7, the function is continuous. But at -7, the function is called discontinuous. It's going to be at x equals -7, and then because there's a break at -7, you pick up your pencil. Also, do you see at this asymptote, which is x equals -5, it's also discontinuous at x equals -5. And the next place it would be considered discontinuous is at x equals -3. Everywhere else on the graph it is continuous, even right here. Do you notice right here? You don't ever pick up your pencil when you're drawing this graph, so it is continuous. So continuity is something we're going to be talking about throughout the year, and you'll start to get more and more familiar with it, but it's a pretty simple concept. Now, with that being said, we're going to start talking about differentiability. Okay, a function can be continuous but not differentiable. Be continuous but not differentiable. Now, at the same time, if a function is differentiable, it has to be continuous. And a function is differentiable if one of two conditions exist. Basically, a function is differentiable if it has, okay, this recording paused a minute ago and I'm not sure exactly where it paused, but what I was saying is a function is differentiable as long as it has one tangent line, and also as long as that tangent line is not vertical. So here are some examples of some functions that are that are continuous. These are all functions that are continuous but not differentiable. Because remember, a function can be continuous but not differentiable. Now, there doesn't exist any case where a function is differentiable but not continuous. Okay, so this first graph shows a function right here that is continuous at A. Does everybody see that? That it's continuous at A. You don't ever pick up your pencil, but it's not differentiable because at A, do you see that there would be multiple tangent lines? That the slope of the tangent line just to the left of the point A and the slope of the tangent line just to the right of the point A are two different slopes. So for that reason, this is not differentiable because there's no one tangent line. Okay, in this case, again, we've got a continuous function. You never pick up your pencil, but at the point A, there's no one tangent line. You have multiple lines that could be tangent to this graph. Here's another case where there's no one tangent line. It is continuous. You don't ever pick up your pencil, but there's not one tangent line that would make this function differentiable. You have to have one tangent line. And then lastly, here is a graph that is, again, continuous, and it has one tangent line, but that one tangent line is vertical. And remember, when you have a function that has a vertical tangent line, it's not a function. So for that reason, you can't use the slope of that, or the slope, sorry, you can't use the slope of that tangent line because it has no slope. Oops, no slope. So instead of saying not a function, that it would make more sense to say that it has no slope. Let's erase that. So because there's the tangent line is vertical, that tangent line has no slope, and so it's not a differentiable function. So I hope the explanation here helps you with the 2.5 prep quiz, and I will see you in class on Thursday.